Salutations! Welcome back to my board. Today we're learning about the laws of indices. Before we start with any laws, we have to learn what are these indices. Indices is the exponent of a number, which shows how many times the base will multiply itself. Take this as an example of what we are defining. 2 in 3 place. 2 is the base and 3 is the index. Yes, indices can also be referred to as index. This index will show how many times the base will multiply itself. The base multiplies itself like 2 times 2 times 2. As you can see, 1, 2, 3. The index, 2 times 2, 4. 4 times 2, 8. 2 cube, as you can also refer to as 2 cube, or 2 raised to the power of 3, is equal to 8. The index now shows us how many times the base, which is 2, will multiply itself. Now let's move over to the laws of indices. So this is law 1. A raised to the power of m times a raised to the power of n. It says that a raised to the power of m times a raised to the power of n is equal to what? Let me give you an example for what the law will state. Let's use a common number. 5 raised to the power of, let's say 3, times 5 raised to the power of, let's say 2. As you know, 5 raised to the power of 3 is 5 times 5 times 5 times this times 5 raised to the power of 2 is 5 times 5. If you remove this bracket, you get 5 times 5 times 5 times. We removed all these brackets. 5 times 5. You can see it as 5 5s. But there's a very easy way to do this. You pick one base. Since both bases are identical, you pick one base. And you now write 3 plus 2. And you add their exponent, which is 3 plus this 2. 3 plus 2 is 5, which will give you 5 raised to the power of 5. You can see it's basically the same thing that we got here. If we expand it, we get 5 times 5 times 5 times 5 times 5. So it's basically the same thing. You don't have to use all this long method where we can just do simple addition. Now that I've given an example of what this rule is, we can now put our knowledge here. We pick one base, which is A, since both bases are equal. So you pick one base, A. And what is the index? M and N. You add this M and N together. M plus N. That is basically the law. Now, let's move over to law 2. So, let's move over to law 2. As the law states, A raised to the power of m divided by A raised to the power of n gives what? Let me use this as an example to clear up what the law states. We write 5 raised to the power of 3 divided by 5 raised to the power of 2. It's basically the same thing as writing 5 times 5 times 5 divided by 5 in 2 places is 5 times 5. But we can write it like this: 5 times 5 times 5 over 5 times 5. 5 cancels this 5 and 5 cancels this 5, leaving us with only 1 5. But there's another very easy trick that you can do. Like we did for the multiplication, we pick out one base, 5. Instead of adding, we subtract the two exponents. It's 5 raised to the power 3 minus 2. 3 minus 2 is 1. 5 raised to the power of 1. And I've told you before, 5 raised to the power of 1 is still the same thing as 5. Didn't we not get the same 5? Now that I've given an example of what the law states, we can get back to am divided by a raised to the power of m divided by a raised to the power of n. We pick out one base, since both of them are identical, and we subtract the two exponents, m minus n. And that is another law. Now, let's move over to law 3. It says here in law 3, a raised to the power of m into bracket raised to the power of n. And like we did here, we're going to write out an example to further explain this law. Let's do 5 raised to the power of 3 into brackets raised to the power of 2. Maths, brackets are basically considered as times, so we can just do this method. No, that's wrong. Let me give you an example. 5 in 3 place is basically the same thing as 5 times 5 times 5 raised to the power of 2. Now, all of this raised to the power of 2 will give us 5 times 5 times 5, close bracket, and the other one, 5 times 5 times 5. Note, when any number is surrounded into brackets and it has a raised to the power outside, that means the raised to the power affects everything. You can see is different from 5 times 5 times 5 square. That means the 2 only affects this 5. But if you do it in bracket here, then bracket here, that means the 2 affects all these places. If we remove the brackets, we will get 5 times 5 times 5 times 5 times 5 times 5, which is 5 in 6 place. But there's an easier way. No, it's not by plussing. It's by multiplying. We put this 5, we put it here, and this 3 times 2, and that will give us 5 in 6 place. We got the same answer without even needing to spend half of the time. Now that we have acquired the example to further explain this law, we can now solve this law. A raised to the power of m, and they are into brackets raised to the power of n. It's a raised to the power m times n. That is our third law. Now let's move over to the fourth law. It says here in law 4, a raised to the power of 0 is what? Like I did in my number-based video, any number or letter raised to the power of 0 is 1. You haven't heard it before? Then go and check out my number-based lesson. We have done part 1 to 4 just for you. And do me a favor, after watching this video, you can go over to the number-based lesson and further your knowledge more on number bases. Now, let's move over to law 5. It says here in law 5, a raised to the power of minus n. We have never done minus before, so how are we going to do this? First of all, let me give you an example to further your knowledge more on this law. Let me do 5 raised to the power of minus 2. So, 5 raised to the power of minus 2 can also be written as 5 raised to the power of 0 minus 2. Because of 0 minus 2 is still the same thing as minus 2. We can just write this 0 here. Now, remember, when we have something like this, what do? We go to law 2 over here. So, you will refer back to the law in law 2. Instead of picking one base and doing the subtracting, now doing it reversely, which is 5 raised to the power of 0. We start from this 0. Divided by 5 raised to the power of 2. Because of the minus is already gone, it's part of the law. If we try to combine this, we pick 1, 5 raised to the power of 0. This 0 minus 2. We basically got the same thing. But we don't write it like this. No. You can also write it like this. 5 raised to the power of 0 over 5 raised to the power of 2. Like I did in law 4. 5 raised to the power of 0 is 1. And 5 raised to the power of 2 is basically 5 raised to the power of 2. That is our answer. Now let's move back to the law. It says a raised to the power of minus n. But instead of going through all that long process, I have an easier way of solving this entire thing. The minus here will change to 1 over. And we put what is left at the denominator. And you know what is left. A raised to the power of n. We put a raised to the power of n. It's basically our answer that we got here with absolutely less the time. Now, let's move over to law 6. So, now let's move over to law 6. It says here in law 6, a raised to the power of m divided by n is what? So what did you do? You draw a square root and the denominator, you put it here. So the n root of the base, you put it here. And where is m? All of this into bracket raised to the power of m. It's that easy. Now let's do it the same thing for this law over here. We draw a square root. What's the denominator? N. What is the base? A. And all into bracket raised to the power of 1. But we don't write raised to the power of 1 because of all of this raised to the power of 1 is still the same thing. So we don't have to write raised to the power of 1. So now, let's move over to law 7. So, this is law 7. It greeted us with AB into bracket raised to the power of m. What do? Remember that I said in my former laws that when a bracket is enclosing a base and there's a raised to the power near it, the raised to the power affects everything that is here. So, instead of writing a b raised to the power of m, we write a raised to the power of m and b raised to the power of m. The same law applies for fractions. A raised to the power of m over b raised to the power of m. Very simple. Now, let's move over to law 8. So, now, let's move over to law 8. It says here, a plus b into bracket raised to the power of m. Wrong. It is not equal to. So this is basically like a warning law. This is not equal to this. Same as subtraction too. A minus b into bracket raised to the power of m is not equal to a raised to the power of m minus b raised to the power of m. Now, let's move over to law 9. This law states that a raised to the power of m is equal to a raised to the power of n. What do? This base, if they are equal, we cancel them, leaving only raised to the power of m and raised to the power of n. So, but we don't write raised to the power of m equal to raised to the power of n. But we change this raised to the power to a base. So, our answer is going to be m is equal to n. That is how law 9 is. Now, let's move over to our last law, law 10. Now, let's move over to law 10. This one is a little bit tricky because of it says minus a into bracket raised to the power of m. What do we do? Well, this one technically has two answers. It's going to be minus a raised to the power of m if this m right here is an odd number. And you know odd number, there are 1, 3, 5 and more. It's going to be minus a raised to the power of m if odd, and a raised to the power of m if even number. And you know even number 2, 4, 6. Technically, m, we don't know if it's odd or even. So technically, this has two answers. Let's move over to another example of this law. A minus a raised to the power of 4. So, what do? My 4 is an even number. So, instead of writing minus a, we write positive a raised to the power of 4 because it is an even number. Now, these are all the laws ranging from law 1 to law 10. Check out my other videos if you haven't, and I'll see you next time. Goodbye.